Welcome back, winners. Last time in the last video we ended on 2.1, and I said we'll do 2.2. I said we'll do 2.2, 2.3, and 2.4. So now let us recap with 2.1, which is this one. The question was determine the equation of a straight line. We read the first part. They said determine the equation, and then what comes to our mind is this formula, the standard form for equation of a line. And then if you look at this formula, we have y1, and then we have x1, and then we have m. Remember I said y and x, they are there to determine the equation. So now we need to substitute y1, x1, and m. And I said y1 and x1 it's a coordinate. They represent a coordinate that a line passes through. So this line passes through the coordinate coordinate C. Sorry, how do I know it's C? Because they told us it passes through C. So now if it passes through C, we know that this will be our x1 and y1 in the equation of a straight line. So now we are set for y1 and x1, but we are not set for m. So now how will you find m in this equation? Remember, we said there are different ways to find m. So now we said, how do you find m? For parallel lines, if two lines are said to be, let me fold the paper. We said 4 ways to find gradient. The second one was parallel lines. So now if we look at this situation, we don't have a point that we can use to find the gradient, maybe a second point to use to find the gradient. So now we need to resort to the parallel lines. Since they said this line is parallel to that line, what we know is parallel lines have the same gradient, so we can find the gradient of that line and equate it to the gradient of that line. So now hence we said the gradient of line A of that line is equal to 8. Why are we saying 8? Because the gradient of AB is 8. Since they are parallel, they will have the same gradient. That's how we got the gradient 8. And then we just substitute y1, which is our point. We substitute x1, which comes from our point C there. And then we substitute m, which is 8. And then we found the equation. So now, winners, let's go to 2.2 and see what we can unpack about 2.2. So 2.2 says, prove whether triangle ABC is isosceles or not. Now, before attempting, think about isosceles. If a triangle is isosceles, what we know is two adjacent sides has to be equal. So now if we can prove that the two adjacent sides are equal, and then triangle ABC, we can conclude by saying triangle ABC is indeed isosceles. So now how will you prove this thing? It's important. To prove isosceles, we need sides. So we can find the sides, all the sides. So now let's go ahead and do that. Let's start with AC. Let's start with AC. So now the length of AC, the formula is square root of x2 minus x1 squared plus y2 minus y1 squared. So now let's go ahead and name our coordinates. Since we are focusing on A and C, are you aware we have naming already? We have x1, y1, we have x1, y1. So now we can make one coordinate be x2 and y2. So we made CB x2 and y2. So now let's go ahead and substitute. So now what's going to be our x2? We go to the sketch. Our x2 is going to be -3. So we will have -3 for x2 minus what's going to be our x1. We go, remember we're focusing on AC. Our x1 is going to be 4. Simple. So we have 4 all squared. Don't forget that squared, guys. then what's going to be our y2? We go, okay, since this one is 2, there is our y2, it's going to be -2. So that's -2 minus, and then we go, what's going to be our y1? From our naming, it's clear that our y1 is going to be 3. So we have 3. Don't forget that squared learners. Please don't forget that squared. And then we go and substitute into the formula. So we have -3 minus 4 squared plus -2 minus 3 squared equal. Beautiful. We get the square root of 74. So we have AC being the square root of 74 units. So now let's go ahead and find the other side. So what's going to be the second side? We are done with AC. Can write it, can put a tick there, and then we are going to find now this one, which is AB. So now writing the formula, AB is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. So we have the square root, the big square root, and then substitute now. So now we go to AB. Here is AB. What? You see we have the correct naming, x2, y2, x1, y1. So nice. We smile. So now we're going to substitute now. The formula says x2 minus x1. So now what's going to be our x2? So it's visible that our x2 is going to be this value. So that value is 3. So we'll have 3 minus. Then we're going to look for x1. Remember our focus is on AB. What's going to be our x1? Our x1 is going to be 4. Nice. So we have minus 4 all squared. Winners, don't forget that squared. Don't make that mistake. So bracket, then what's going to be our y2 according to the formula? So here is our y2. That's going to be -5. We have -5 here minus, and then what's going to be our y1? So if you check here from the naming, that's 3. Guys, analytical geometry is just walk in the park, because just check, we just calculated the length of AB without working, because we just name and then substitute. That's what we did. So we substitute that 3 minus 4 into our calculator. Don't forget squared winners. So -5 minus 3 squared, and then equal sign. So we get the square root of 65. So now we know, okay, so far we know AC is square root of 74, and then we know AB is square root of 65. So now we go and find the last side, so which is CB or BC. So now here we can find the length of BC. So BC will be the square root of x2 minus x1 squared plus y2 minus y1 squared. So now we go to the sketch. We have the naming, but the problem with the naming is that we have x2 and y2, and then here we have x2 and y2. So we need to change one, at least change this one, have x1 and y1. No problem. So now the formula says x2, the formula says x2 minus x1. So now let's go ahead and find our x2. So it's clear that our x2, that's 3. So we will have 3 minus. And then what's going to be our x1? Our x1 is going to be -3. So now this negative and this negative, they will make positive. So we have +3 squared plus, and then what's going to be our y2? We go to the sketch again from our naming. So we have y2 as -5. So we will have -5 there minus, and then what's going to be our y1? we go, this is y1, that is -2. So we have a negative and that -2, and then that's going to be +2, all squared. Winners, don't forget that squared, because if you forget that squared, your answer will be wrong. So now we use our calculator, squared plus, okay, we put everything as it is, all squared. What's the answer? Is 3 root 5. So we have 3 root 5 units. So now let's go and make a conclusion. We have all the sides. We have AC, we have AB, and then we have BC. But none of them are equal. So therefore, our conclusion is triangle ABC is not, thank you, is not isosceles. So why are we saying it's not isosceles? Because we don't have two pairs of equal sides. If we had two pairs of equal sides, we were going to say that the triangle is isosceles. So now, if the question asks you to prove whether a triangle is isosceles or not, what do? You find the length of the sides. After finding the length of the sides, you'll see if you have two equal sides, you'll make a conclusion that the triangle is isosceles. So now let's go to 2.3. So now continuing with 2.3. 2.3 says A, B, and D. Okay, let's go ahead and find the D and put D somewhere. So we have A, we have B, and then if we were to extend it, okay, let's extend this direction. So we have D there. So with the coordinates x is to 5. So that's what we have. Or you can put it anywhere. Even if you put D here, it does not matter. We just want to create a picture or an image. So we have A, D, B, or A, B, D. As long as it's A, B, D, as long as you have A, B, and D. So this is the image that we have. Let's draw that image here. So this is 1, 2, 3. So let's say this is A with 4 is to 3. And then let's say this is D with X is to 5. And then let's say this is B with 3 is to -5. So this is the picture that we have. They say these 3 points are collinear. Why did I put D on that line? Because the statement said they are collinear. So now, remember, guys, if they say that the 2 points are collinear, so this is the information that we know. If the 3 points are said to be collinear, this is what we write. We start by writing the gradient. So the gradient of each two pairs will be equal. So now, coming here, we will do the same thing. So now, am I wrong if I say the gradient of BD is equal to the gradient of AD is equals to the gradient of AB? So now, how did I grade this equation? I graded it using the concept of collinear points. If the points are said to be collinear, the gradient is the same between any 2 points. So now, let's go ahead and substitute using the formula m equal y2 minus y1 over x2 minus x1. So now, for the first one, what I'm going to do, I'm going to name BD. So I'm going to first focus on BD. So I'm going to focus on BD. So I can make this one x1, y1, this one x2, y2. So now making substitution for in the gradient formula, we have y2. So now what is our y2? From the naming, we can see that our y2 is 5. So we will have 5 minus, and then what's going to be our y1? From the naming, as we can see, our y1 is going to be -5. So this negative and that negative from the number will be positive. So we have plus 5 over. And then what's going to be our x2? So from the naming again, our x2 is going to be x. So we have x minus, and then what's going to be our x1? Our x1 is going to be 3 equal. So we're done with the first part, which is finding the gradient for BD. So we're going to find the gradient for AD. So AD, this we're focusing now, we're done with the two. So for now, we're focusing on those two. So we need to name. So now, since we have x2 and y2, for A, we can have x1 and y1. So now let's go ahead and find the gradient. The formula is y2 minus y1 over x2 minus x1. So now from the naming, we need to find y2. So our y2, we said it's at D. So we will have 5 minus, and then what's going to be our y1? Then our y1 comes from A, which is 3 over. And then from this point, since we are finding the gradient of AD, what's going to be our x2? So if you check here, your x2 will be x. So now we will have x minus, and then what's going to be our x1 from the naming? That's going to be 4. So we're done with finding the gradient for AD. Are you aware that the first two parts, or the first two gradients, they have a variable in them? So now we need to move to the last one, which is the gradient of AB. So we're done with the two. Now we're focusing on those two, the gradient of AB. So if you check AB, A and B, they have x1 and y1, x1 and y1. So we need to change, at least have x2, y2. So now substituting into the gradient formula, what's going to be our y2? From the naming, we can see that our y2 is going to be negative 5. So we have negative 5 minus, and then what's going to be our y1? y1 is going to be 3. So we have minus 3 all over. So what's going to be our x2? X2, there it is. X2 is going to be 3. So we have 3 minus. And then what's going to be our x1? Remember, we're focusing on AB. So our x1 is going to be 4. So now let's try to simplify, to clean up this thing. So now what is 5 plus 5? That is 10 over x minus 3 being equal to, and then what is 5 minus 3? That is 2 over x minus 4. And then that one, since we have numbers, we can substitute it into the calculator. So we have negative 5 minus 3 all over 3 minus 4. What's the answer? The answer is 8. So now it's up to you. You need to take any two equations. So you will decide any two equations to find x and equate them. But you need to take one, the one with full information, or the one with no variable, and the one with a variable. So the one without a variable is this one, and the one with a variable is that one. So we can take 10 over x minus 3 being equal to 8, and that 8 over 1. And then from there we cross multiply. So now what is 8 times x? That's 8x. And then 8 times 3, that is a negative 24, equal to, then 10 times 1, that is 10. And then we have 8x equal to, if we take 24 to the other side, we will have 10 plus 24, and then 8x will be, so 10 plus 24, that is 34. And then putting that in a calculator, 34 divided by 8, sorry, not by 5, divide by 8, that's 17 over 4. So x is equal to 17 over 4. So now let's check with a different one to see if we get the same answer or a different answer. So now with that one, or with this one, we can equate 8 and that one. So we will have 2 over x minus 4 equal 8 over 1. And then with cross multiply, and then 8 times x, that's going to be 8x minus, and then 8 times 4, that's going to be 32. So we have minus 32 is equal to 2. So if you take the negative 32 to the other side, you will have 8x equal 2 plus 32. So 8x will be 34. And then the last step, you divide both sides by 8. Divide by 8, x will be 17 over 4. You see, they give us the same answers. So now, since we know the value of x, it's going to be, so the coordinates of d is 17 over 4 and 5, because they gave us 5. So that's how you find the unknown if they tell you that the points are collinear. You find the gradient, all the possible gradient between your points, and then you take the one which has no unknown, you equate it to the one with unknown, and then you can solve for unknown. So it's up to you, you decide. You see, the two gave us the same answer. So if you take this one, you'll get the same answer. If you take that one, you'll get the same answer. So now guys, going to 2.4. Going to 2.4. Let's go to 2.4. 2.4 says determine the size of CAB. So this is an angle and we need to identify this angle. So now, where is CAB? This is CAB. Now let's go ahead and highlight that. This is CAB. Sorry. So let's go ahead. This is CAB. So which angle are they talking about? And they're talking about angle A. So they're talking about this angle. So we need to find that angle. So what I'm going to do, I'm going to redraw this thing, and you'll tell me if it's wrong or what. But I don't want to involve most parts. I just want to involve few parts. And I'm going to show you something. They want that angle. That is A, and then we have C there, we have B down there. So now I want us to look at this triangle. I'm going to highlight it. Okay, sorry. Let's look at this triangle. So now if you look at that triangle, doesn't it remind you of this triangle? Let's say you have A, you have B1, B2, and let's say that's C. You learned about exterior angle of a triangle. You learned that B2 equal A plus C. So now, and from the information that I gave you, I told you that you need to make use of the exterior angle of a triangle. So now, you need to compare this triangle and this triangle that you have. So what is B2 in this figure is this angle. So let's give it a name. Let's call it alpha. And then what about this one? You see, let's call it beta. So using the same theorem, are you aware that theta or alpha equal A plus beta? So what's going to be the reason? Exterior angle of a triangle. So now what does that tells us? That tells us we need to find alpha and we need to find beta. Once we can find alpha and beta, and then we can find the answer to this problem. So now, what is alpha? Are you aware that alpha is an inclination to AB? And now how do you find inclination? We said we use the formula m equal tan of alpha. So now you need to ask yourself, if we take the angle alpha, which line are we talking about? We are talking about the line AB, because the alpha is an inclination to line AB. So that means we need the gradient of AB. But if we go back, we did find the gradient of AB. So the gradient of AB from the first question was 8. So now what we can do is we can just substitute 8 here. So 8 will be tan of alpha. And then we can use the concept of solving, or the idea of solving trigonometric equations to find alpha. So alpha will be tan of 8. So now alpha will be, so if you put that in a calculator, tan 8, that is 82.87. So that is 82.87 degrees. So now we are going somewhere. We have alpha. So now we need beta. So now ask yourself questions. What is beta in this triangle? Beta is an angle of inclination. Why? Because it's measured from x-axis to a line, and even alpha is an inclination because it's measured from x-axis to a line. So now we need to find the size of this angle. So now if it's an inclination, that means we can find it using m equal tan of beta. So now it's going to be the gradient of which line? Since beta is an inclination to line AC, that means we are going to talk about the gradient of line AC. So now we need the gradient of AC. So now how will we find the gradient of AC? Let's go back. Okay, we're gonna have to find it manually. So now the gradient of AC will be y2 minus y1 divided by x2 minus x1. So now what's going to be our y2? So now we go to AC. So now we go to AC. So here is AC. You can write the coordinates there. We have A with the coordinates 4:3, and then we have C with the coordinates -3:2. So these are the coordinates that we have. Remember, I said you have to name. So this can be x1, y1, and that can be x2, y2. So now finding the gradient, what's going to be your y2? Y2 is going to be the -2 minus, and then what's going to be our y1? That's going to be 3 over, and then what's going to be our x2? Our x2 is going to be -3. So we will have -3 minus, and then what's going to be our x1? Our x1 is going to be 4. So we have -4. Therefore, the gradient of AC, if you put that into the calculator, so we have -2 minus 3 over -3 minus 4. So it's going to be 5/7. So the gradient of AC is 5/7. So now if we have the gradient, and then we can find the inclination, so we just take this 5/7 and substitute it there. So we have 5/7 being equal to tan of beta. So now we can find the beta. So beta will be arctan of 5/7. Therefore, beta will be, so if you put that in your calculator, arctan 5/7, that's going to be 35.54. So we have 35.54 degrees. So now we go back. What did we say here? We said, okay, let me finalize that here. We said alpha, okay, alpha, alpha, we said alpha equal a plus beta. The reason is exterior angle of a triangle, but we know what is alpha. Here is alpha. We know the value of alpha. So there's the value of alpha. So we are going to substitute it here for that alpha. So that's going to be 82.87 equal. And then what is A? A is the angle that they want, which is CAB. So we can call it A plus. And then what is beta? We know the value of beta here. We found the value of beta. And then now we just are gonna substitute it there for beta. So we will have 35.54 degrees. And then transposing. So we will have 82.87 minus 35.54 degrees equal A. So therefore, the value of A will be, using a calculator, 82.87 minus 35.54. So that is 47.33. 47.33 degrees. Therefore, CAB equal 47.33 degrees. So guys, it's a long procedure, but if you go through such questions whereby you have to use exterior angle of a triangle, I think you will get used to these problems. So thank you very much. This is where we end. We'll meet in the next video where we'll be discussing a different question